Welcome to the video that provides a walkthrough of frequently made mistakes found for assignment 2B. First and foremost, please make sure to comment your code thoroughly. A number of people are getting the wrong solution, but since there's no comments in their code, it's difficult for me to figure out what they were trying to do in order to provide more effective feedback. Always make sure to comment your code. It's a good habit to get into, and it's important for doing well on the final version of the solution. Let's start taking a look at problems we see in the Simple Semaphore class. A lot of people had problems with this class. It's really not that complicated, but you have to pay careful attention and make sure you go back and watch the videos on Rantrent Lock and especially Condition Object. First, you need to read the specification carefully for the mpermits or the permits field, whatever you wanted to call it, that goes in the class. You have to make sure that your implementation meets the specification, which is to ensure atomic reads and writes to memory without going through processor caches. So make sure you do that properly. Here's a hint. It does not require the use of any class. It just requires the use of the appropriate type qualifier. Likewise, under no circumstances should you define this field to be static. Static, as you may recall, means there's only a single instance shared by all the instances of the classes, where of course we want each instance of single semaphore to have its own permit count. Here was another rather odd problem I saw. Someone attempted to provide a wrapper using the atomic integer field updater class, which is rather clever, but quite overkill for this particular assignment. Rather than trying to do this, which is going to have a lot of extra overhead, just make sure that you use the appropriate type qualifier on the permit count field. Let's take a look at an example of a problem I saw with the simple semaphore constructor. This person was initializing the permit count to the number of available permits, which of course makes no sense at all. You need to take a look at the parameter that's being passed in to the simple semaphore constructor. Likewise, this person was not initializing any of the other fields in the class. They weren't initializing the lock field, they weren't initializing the condition object field, so of course their program was guaranteed to blow up with null pointer exceptions. And I'm a little surprised because this would trivially have been caught when running the unit tests. So make sure that you run the tests, make sure that you look for problems that the tests indicate, and go back and fix your code accordingly. Or, of course, come to office hours if you have questions. Let's take a look now at some of the problems with acquire. There were many, many different problems with acquire that people had. This particular person was attempting to create a new condition object inside of acquire, which made no sense at all. That type of initialization should be done in the constructor one time. Another very common problem I saw people do was they checked while mpermits equaled 0. You have to remember that it's perfectly legal to give a simple semaphore, or any Java semaphore for that matter, an initial value of negative. So it could be -1, -2, -3. That's a perfectly valid value. And if you do that, it'll turn out that mpermits may be less than 0. So if you just check to see if permits equal 0, you're not going to be able to handle that case properly. So make sure that you handle this. You'll see a bunch of other examples of how to do this and where the problems are. Likewise, this code also has problems because there's no locks. And so as a result, the mpermits value will not be properly synchronized or protected from concurrent access. And the lock also won't be held when the person calls await on the no permits condition object, which will also give you a problem. That should throw another exception. So this code is full of bugs. Down here, you can see that, again, it's very strange. Why are we going to be calling signal all here in acquire? That makes no sense. The signal mechanisms are used to alert someone that something may have changed to allow them to be able to wake up from their awake calls, and that certainly does not belong here. Here's another example of some problems with try acquire. You can see that the person is starting off by trying to call trylock. Don't understand why trylock is being called here. It's certainly wrong. And of course, there are no comments in the code, so it was not possible to try to understand why the person thought that was a valid thing to do. Once again, don't loop while mpermits equals 0. You need to do less than or equal to 0. A lot of people had problems with acquire uninterruptibly. In fact, many people had problems with this, so I'll try to explain it here. Uh, first of all, this code is coming in, and it doesn't make any sense what it's doing. It's not using the condition object correctly, and it also doesn't handle interrupts correctly. So I'm not even sure what this code is supposed to do, but it's very wrong. A number of people tried to call await uninterruptibly on the condition object. The problem there is that it's not guaranteed that await uninterruptibly will set the interrupted flag properly. So you can't use await uninterruptibly. Instead, what you need to do is you need to use await, and you need to do it inside of a loop. And you need to check to see whether or not there's an exception that occurs by catching the exception and then setting a flag. And then if that flag is set, then you go ahead and set the interrupt flag at the very end of the method. This example here is another example of the same problem. The person is not looping properly, so don't have your code do a top-level try-catch block, because what will happen there, of course, is you'll just turn around and sort of return, whereas you're supposed to be looping, so you don't in return. That's the whole point of acquire uninterruptibly. We have to mark the fact that an interrupt did occur by using a local variable flag. This person had a strange idea of calling the acquire uninterruptibly method recursively, which is a really bad idea. And it's too complicated, it's inefficient, and you could lead to Stack Overflow if you're not careful. Make sure that you don't decrement M permits in the finally block. That needs to occur inside the try portion of the try catch block, the try catch finally block. And the reason for that is that we do not want to be decrementing the permits count if an exception of some kind occurs. That would make no sense. Likewise, you don't want to be calling thread interrupted unilaterally, because you don't know whether the thread was interrupted in the finally block. It might have actually gotten here under the right circumstances with no interrupts. So instead, you have to have a local variable that you would check to see if interrupts occurred. Now that we've talked about problems with acquire, let's talk about problems with release. So here's release. For some strange reason, this person was calling unlock as the first thing they did in release, which of course makes absolutely no sense, because the goal of using lock is to make sure that you have a critical section where no other threads can be running at the same time. So unlocking, first of all, the lock is not already held, but secondly, even if the lock were held for some reason, you wouldn't unlock it as the first thing in. Likewise, we're in release, so why are we looping to see if permits equal 0? That's really what acquire does, although you need to make sure you do less than or equal to 0 in acquire. And this person is also making the very tragic mistake of calling the wait method instead of await, number one. So don't be calling wait. Wait's part of the Java object as opposed to await, which is part of the condition. And secondly, it makes no sense in release to call wait or await. That's just a nonsensical thing to do. So this code is very broken. Similar problem down here in this version of release. This person, for some reason, is calling notify, which is also a bad thing to do. You want to be calling signal, not notify, on the condition object. And also make sure to only call signal if the permit count is greater than 0. If the permit count is negative, or 0 for that matter, there's no point in calling signal, because no one's going to be able to make forward progress anyway. Here's another common problem I saw in release. A lot of people didn't acquire the lock properly, didn't release the lock properly, and didn't use the condition object correctly. So this code won't do anything useful. And a similar problem here. This person really had just about no useful code whatsoever. Also, make sure that you call signal, not signal all. Signal all doesn't make any sense at all. So don't call it. Remember, that would lead to the thundering herd problem. Now that we've finished dissecting frequently made mistakes with simple semaphore, let's turn our attention over to the Palantir Manager implementation. Here's the acquire method, and here's a common problem I saw. Make sure you don't use the put method inside of acquire. Instead, use the entry.setValue method, which is much more efficient. No sense using put. It's overkill and inefficient. Another problem here is that this person is acquiring the lock inside of a conditional statement in the try portion of the try finally block, but only if Palantir doesn't equal null. And yet they're always unlocking the lock. So it's possible, depending on the circumstances for which this method is called, for unlock to be called without lock ever being called. So don't do that. There's better ways to structure the code. Along the same lines, make sure you always check to see if the Palantir is not null first before you do anything else. If it's null, just go ahead and bail out. Likewise, there's no need to use get and put together. All you need to do is simply use put. Likewise, you don't need to use something like the replace method either. Neither of those are necessary. And here's a rather unusual situation where the person set things up so that if an exception occurred, the semaphore is not released. So make sure that you always release the semaphore properly, but also make sure you don't bother trying to release the semaphore unless you are successful at putting the right value into the Palantirian map, putting true, indicating that the Palantir is now available. So don't just release it unilaterally, only release it if things are in the right state. So that's essentially a summary of the common problems that I saw in the solution. By far, the biggest problems were in the simple semaphore implementations. People did lots of very odd things there. So make sure you go back, rewatch the videos on reentrant lock and condition object especially, and also make sure you watch this video and take a close look at the various comments I gave you on your code. So that's all for now.